Look, in this video, we're going to go over the derivatives of exponential and logarithmic functions. And this is in chapter 9, a bit farther, and it's a bit of length away from when we first learned differentiation with the power rule, chain rule, whatever, friggin' product rule, quotient, all that stuff. It's quite a while away, so let's just try to refresh our memories with these exercises. And let's start off with the exponential function. It's probably the easiest one. And it's given in your book as well. If I pull it up, right here, if I pull it up, you guys can see the facts are given right there. F of x. If f of x is the exponential function e to the power of x, then the derivative is the same thing. So we can just write this down. E to the power of x is e to the, sorry, let's just draw the differentiation operator. E to the power of x is just e to the power of x. And that might seem like the end of the narrative, but it's not, because when we have e to the power of x, it is actually, it is, you can say it's the larger function in chain rule. Recall that chain rule has, a big outside function and the function within, and you have to differentiate the function within and multiply it by the derivative of the big function. So let's actually try to bring some sense to what I just said. If we have a function of, find a better fucking color right now, function of e to the power of 4x, okay? What is the function within? Well, clearly the function within is 4x. Let's draw that out. 4x is the interior function. And so what we'll need to do is we can make some substitutions actually. We can just say, finding colors is just a pain in my ass, right? Here we go. We'll just say, okay, we'll just say this is actually just e to the power of u, where u equals 4x, and du dx equals 4. And since we know, if you look at the formula booklet, you can find this. Since we know that dy over dx is equal to du dx times dy over d. Actually, that's a very. Let's do that. The horizontal line. I said dy du. These cancel out, and we get dx dy. And so if we differentiate u in terms of x, then we get 4. That is what we're going to multiply dy du as. And y is equal to e to the power of u. And since, as we written up here, e to the power of anything is just e to the power of that thing. And so what we've done here is the same thing. We've just changed x to u. Or we've actually made a substitution, but let's just keep it simple. U is just x, and so if we're differentiating dy in terms of du, then we just have e to the power of u. And since we have to multiply, remember this is a function within a function, so we have to apply chain rule, and we have to multiply by du dx. Du dx we've already determined right here. So what will this be? Well, that will be 4e to the power of u, and since u is 4x, we have 4e 4x. So essentially, when you have a function like e to the power of ax, basically, look, just move that a to the front. All right, move the a to front. All right, there, and then and that's it. That is it. E to the power of ax, differentiate that. That's just ae to the power of ax. That's what we've seen up here. All right, that was a bit of a mouthful. But now let's move on to the logarithmic functions that you guys will be given in the SL course. Logarithmic functions, almost as easy as this, really. We're applying the same principles of chain rule here. Let me just pull it out. Yep, you're given this in your formula books in the exam. Look, if the function f of x is ln of x, which is the natural logarithm, then the derivative will be 1 over x. And so let's just write that down then. If f of x equals ln of x, then df of, whoops, what am I writing here? And df of x, differentiating f of x in terms of x, will be 1 over x. And by the way, you can write df of x and whatever as just f prime of x. Either one would work. Okay, and with this fact, we can try bigger examples. We can say, well, look, ln, let's say 4x, similar to what we've done before. So ln 4x, what's that going to be? Well, it's the same thing. ln of x is the big function. 4x is the interior function. We apply the same chain rule principles here. We can, let's just, say, change the color so it looks nicer. U is equal to 4x du. We're differentiating this in terms of x is simply 4 du over dx times dy over du is just dy is what we're looking for, dy dx. Therefore, if we define our y as ln of 4x, and then we make a substitution, it'll just be ln of u. Du dx is 4, so we can say 4 times, the 4 times dy du of ln u. And what's dy du? What is, ln of u differentiated in terms of u? Well, look, we've been given this formula. If I can open the fucking we've given this formula already. The derivative is simply 1 over x. That doesn't differ from what, that doesn't differ really. The symbol is just different, but there's no difference. So we can just say, look, that's just 4 times 1 over u. And since u is 4x, we can undo the substitution to get 4 times 1 over 4x. Whoops, sorry. Whatever. 1 times 1 over 4x, which is 4 over 4x. And so ln of 4x is simply 1 over x again. And that's actually, if you do enough examples, you'll find that it generally holds. Ln of ax is simply 1 over x as well. I'm sorry, 1 over x, not u. Oops. 1 over x. Perfect. And that's, the way I see it and the way the textbook has given you questions, that should be as hard as it gets. But we'll try another example. We'll try one more example that actually takes advantage of the change of base rule. Look, the easy stuff is this, right? We know that if y, let's change the color. I'm tired of looking at green. Let's change it to like this beautiful purple here. Look, if our y is ln of x, then the dy over dx, right? Differentiating y in terms of x, that's just 1 over x. And that's a pretty easy relationship. We can, use that for quite a lot of things. And so let's try it out, Let's try to apply this relationship to something a bit more complicated. Let's not forget that ln of x is actually just, log base e of x. It's what you have to take e to the power to get a result. So e to the power of, if e to the power of x is a, then log e of a would equal to x. It's the same, it's just another way of writing it. It's we encounter this log base e a lot, and that's why we have a special way of writing it. And so, because of that, we can manipulate this. We can manipulate this easy relationship to, to serve as a shortcut to figuring more complicated stuff. So let's say, we had the question of, y equals log base, let's say 3 of 2x. Okay, now immediately we could tell this is not ln x. It's not in the form of log base e of something. So we can't really use this easy relationship we've got here. But we can try to change things so that it fits this. It fits ln of x, and it fits this easy relationship. We will try to change things by the change of base rule, which is also given in your formula booklet. But just as a reminder, I'm gonna have it up here. I'm gonna pull it up. Change of base rule. The way I remember it is, it's right here, by the way, right there. The way I remember it is, look, you take the big thing and you put it on top, and the small thing goes in the bottom. So if we were to change the base to ln, I'm sorry, let's change the base to e, log e of log e, then as I said, the big thing goes on top, so log e 2x. The small thing goes in the bottom, so this is the small thing, and that will be L log e3. And as I've said previously, and as we've written right here, look, ln x is just log e, so we can say, look, that's just ln of 2x over ln 3. It's important to note that ln 3 is just a number. Okay, it's this ln 3 right here. Let's circle this. ln 3. Sorry for that. ln 3 is just e to the power of whatever to 3. That is ln 3 essentially. It's just a number. It's the number that you have to raise e to achieve 3. So let's just remember that, and let's treat that as a constant. Now, look, now that we have changed the base to e, we see the ln x forming. We see ln 2x, which is brilliant, because now we can use the easy relationship we've discovered on top here. We can use that easy relationship to differentiate. So ln 2x, let's kind of look at them separately now. ln 2x is simply just 2 times 1 over 2x, and that's just 1 over x. Oh, sorry, someone was at the door just now. Okay, anyway, 2 times 1 over 2x, that's just ln, oops, that's just 1 over x again. And so we can substitute that, we can put that back in. We can say, look, that's just 1 over x over ln 3, which is the same as 1 over x divided by ln 3, which is, let's scroll down a bit further, the same as 1 over ln 3. Actually, that's not a good way of writing it, isn't it? That's the same as 1 over x times ln 3. And that is how we can change, things that are not ln x into ln x, and then solve it with the easy relationship that we have up here. And so that is essentially, sorry for the shifting image, that is essentially what we need to do. When you have log not in base e, so not ln x, you need to change the base, with the change of base rule, which is not that hard. Remember, the big thing goes on top, small thing goes in the bottom. Change of base rule, and then first of all, change of base rule and change base to e, and then you can just use ln x, the easy ln x relationship, and that is how we differentiate exponentials and logarithms.